Hey y'all, in this video lesson, we're going to be getting an introduction into radian measures. So up until this point, we have been talking about degrees, and now we're going to switch over to radians. So you may be wondering, why are we switching to radians when degrees are just fine? Well, that's the thing. Degrees are just fine. Radians are great. Basically, degrees are kind of an arbitrary measure of a sector of the circle, and radians are going to be a little bit more exact. Also, they are used more predominantly throughout mathematics as you progress from here on. So in calculus, physics, stuff like that, we use radians instead of degrees. A degree is 1/360th of the complete rotation of a circle. So we're going to kind of use that to convert over to radians. Radians, they're just an alternative way to measure an angle. So you can convert between radians and degrees and use them both as far as solving problems, but later on, using radians is just going to be much easier. A radian is based on the radius of a circle, and I kind of have a picture here to show you where we're coming from when we're talking about radians. 1 radian is the angle created by bending the radius length around the arc of the circle. So they've taken the radius, they've bent it, and they're measuring it around the circle. And basically, when you do that, you get a little over 6 radii. So if you recall from geometry, the circumference of a circle is 2 pi r, where 2 pi is about 6.28, and that comes from 3.14, which is pi, or estimation of pi, times 2. So this confirms that the circumference is a little over 6 radius lengths. A complete rotation is 360 degrees, or 2 pi radians. Those are the same measures. And if we divide both sides by 2, then 1 pi, just pi radians, is 180 degrees. And this is going to help us as we move forward in the lesson to be able to convert between degrees and radians. Let's look at this circle. I have some critical degree measures labeled out on this circle. And we're going to just kind of use some logic to convert these to radians. Later, I'll give you a formula, but for now, let's use some logic. So if we're just talking about these angles here, ignore the other circle for just a moment, then if I'm just focusing on the top half, from here to here is 1, 2, 3, 4 segments. So I'm breaking it up into 4 parts, 1, 2, 3, 4 fourths. So this would be 1 pi over 4, 2 pi over 4, 3 pi over 4, and 4 pi over 4. Now, if I do some reducing or simplifying, this is going to be pi over 2, and this is going to be pi. So we can see here, this is confirmed that 180 degrees is pi. And half of that is at 90, because that's half of that segment, basically. And then if we were to keep going, we would get 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. Forgot 0 to start. Sorry about that. And then reduce. That doesn't reduce. This one does by 2 to get 3 pi over 2. That's 1.5, which makes sense. 1.5. 7 pi over 4 does not reduce. 8 pi over 4 is 2 pi, which confirms with what we found earlier, that a full circle is 360 degrees, or 2 pi radians. So these are going to be notable measures that you will be seeing throughout trigonometry. So you might get yourself familiar with the simplified forms of those. Now I have another circle over here, and the segments aren't drawn, so we can draw those in if that helps. there and right there. And I want you to pause it and try to logically come up with what these measures would be with radians. Pause it, try it, come back and check your work. So hopefully initially you found that there were 6 sectors or sections here. So we're going to be dividing this into 6, basically. So right now in the pink, I have 1 pi over 6, 2 pi over 6, 3 pi over 6, sorry, and so on. And then we do want to go ahead and reduce on the ones that can reduce. So 2 pi over 6 reduces to pi over 3. 3 pi over 6 reduces to pi over 2, which confirms with what we found right here. Same measure. 4 pi over 6 reduces to 2 pi over 3 divided by 2. 5 pi over 6, 6 pi over 6 divides or simplifies to pi. 7 pi over 6, 8 pi over 6 divides by 2. We get 4 pi over 3. 9 pi over 6 divides by 3. We get 3 pi over 2, which also confirms we got that on the other side. 10 pi over 6 divides by 2, 5 pi over 3. And then the last one up here, 12 pi over 6 is 2 pi. So I've got a lot of stuff going on in this picture. I'm going to highlight our critical radian measures because, again, you're going to be seeing these, whoops, wrong one, over and over and over again. You might as well get used to them. Just get real comfortable with those measures. So sometimes when we are working on problems, it may not be these nice, neat, clean radian measures that we see here, where we can logically kind of work out what we know they are. Sometimes we get, I don't know, 272 or something like that. I don't know, I just made something up. And you need to convert that, and we don't know exactly where that is based on the circles I gave above. So we do have these formulas here that can help you. And this is the same as like if you were converting measurements like feet to miles. We use these fractions to kind of help us simplify some of the measurements and end up with what we're looking for. So if we want to get degrees, let's say we were given radians. So for example, down here, I have 5 pi over 6. I'm given radians and I want to convert that to degrees. Then that means I need to basically get rid of the pi. So I'm going to put pi in the denominator and I'm trying to convert to degrees, and I'm going to use 180 because there's 180 degrees in 1 pi radian. And then now the pi's simplify, and then we can reduce these. 5 times 30 is 150 degrees. Now, if I go up to, this one was a nice, neat, clean one, but if I go up to my circle up here and look at 150 degrees, it is indeed 5 pi over 6. So if you don't want to draw the circle or pull up that circle every time, you can just use that little formula there. Now, if we're starting with degrees and we want to move to radians, then we're going to have degrees. We can put it over 1 to make it a fraction. And then I need degrees in the bottom so that they simplify. And I'm wanting to go to radians. So go ahead and try this one. Pause it, try it, come back and check. For this one, you should get 4 pi over 3. I divided both the degrees by 60 degrees, and we end up with 4 and a 3. So that's how you convert with any degree or radian. Use some form of this conversion there. Okay. We got some evaluating examples here. Let's say, so we've already built the unit circle and we did the unit circle with degrees. So let's just picture our unit circle with the degrees and try to find these. To do that, we would need to convert these to degrees. Now in the future, we're not going to convert these to degrees. We're just going to leave them as radians, and we're going to have our unit circle as radians. So in the future, we won't have to go back and forth like this, but we're just practicing for this lesson. So let's just try it. If we do sine of pi over 3, I can either go to the circles that I drew and look at my unit circle and figure that out, or I can convert this to 60 degrees and then think of my unit circle and come up with the solution. So you go ahead and try it. If you remember, if you can picture, 60 degrees is up by the 90. So to get there, we go over a half up root 3 over 2. And remember, sine is the y coordinate. So sine of pi over 3 is root 3 over 2. And then cosine 3 pi over 4, go ahead and pause it, try it, come back. Hopefully you remember that anything with the 4 in the denominator is going to be that root 2 over 2. But if we picture where that is, 3 pi over 4, that's going to decide the sign of our solution. Actually, I think I fast forwarded a little bit. This is associated with 45 degrees, and 45 degrees is root 3 over 2. I'm messing this up. 3 pi over 4 is not 45 degrees. Convert it. Sorry. Rewind. My brain's working too fast. Convert it. Try it. Come back. Sorry about that. What I did teach you, I hadn't taught you about the over 4 yet, but what I did teach you is that when it ends in 5, the degree ends in 5, that's when it's root 2 over 2. And if you picture where 135 is on the unit circle, it's past 90, so that puts us in the negative x values. So sorry. My brain just got ahead of itself. Okay, try tangent 3 pi over 2. Pause it, try it, come back. Convert it first. Don't fast forward like I did. Convert it first, then try it, come back. If you remember the ratio for tangent, it was y over x. So I want to consider the x and y values for 270 degrees. 270 degrees is on the y-axis right here. So that would be over 0, down 1. So that x and y coordinate would be 0, -1. And then the trig ratio, y over x, when we do -1 over 0, remember that when 0 is in the denominator, we call this undefined. And that relates back to the domain and range videos. This is using all the things that we've learned so far. So we get to unpack a lot of things in these problems. And then obviously we can use a calculator for this. I have showed you already a little bit when we had degrees, we had to make sure that our mode was in degree mode. Now, when we're talking about radians, we want to make sure that the mode is in radian mode. So you're going to go to your calculator if you have a graphing calculator. And I believe on like the online calculators, there's just a toggle. It'll have RAD and then DEG, and you just toggle to which one you need. But you're going to go to mode, which is at the top of the calculator. And then you're going to want to make sure that you are in radian. Where's mine? Mine's down here. Radian mode. If we're talking about radians, you need to be in radian mode. And we're going to do a little example here just to kind of give you some awareness of that, because oftentimes when we're working, we forget to check the mode first, and maybe we had just done a problem in degree mode and we forgot to switch it. So you need to have your own self-awareness of trig functions to be able to basically check yourself. So if we're in radian mode, and which I am, I just put it in radian mode, and I type in sine 30. Now 30 is degrees. And actually I'm gonna do sine 60. I'm gonna change that to 60 because I already did 60 up above. Sorry about that. Easy fix in the notes. Sine of 60. I got -0.304, and I know it's supposed to be square root 3 over 2. Those are not the same. So that means, it doesn't mean your calculator's wrong. It means that you typed something in incorrectly. So I need to switch it to degree mode. Now I can type in sine 60 and I should get 0.866. Now you know you're in the right mode. So you still have to have that prior knowledge to be able to figure that out. And you can do that with sine 30. With sine 30, it's a little bit easier because sine 30 is a half. So if I type in, mode, I'm going to switch it to radians to show that when it's in radian mode and I type in sine 30, I should get a half. And I do not. So that's how I know I'm in the wrong mode. I'm talking about degrees in this instance. Sine 30 should be a half. There you go. So just make sure you check that before you start homework or start any problem. Make sure you're in the right mode because you will get incorrect answers based on that. So we got negative 0.988 and it should be a half. So important step. All right, that's all I have for this lesson. I hope you enjoyed it. If you have any questions, please let me know. I'd be happy to help, and I'll see you in the next one.